everyone, my name is Miguel Davila. I'm an Autodesk Fusion 360 Catalyst, and today I have a fun workflow for you. Today we'll be making Christmas ornament, but not just any Christmas ornament. We're gonna take any mesh, find the center of mass, and then create an attachment point above that center of mass so that when you 3D print it, it's nice and balanced. In order to do this tutorial, you'll need two things. One, you'll need your file. You'll need an STL file and an OBJ, any mesh file really, preferably one that's already solid. You can also edit a 3D scan of an object, and I'll show you how to do that, make a solid out of that in another tutorial. And you'll also need the Python script or add-in called centerofmasspoint.py, and it was developed by these guys over in the Autodesk Fusion 360 Evangelist team. What it does is that for all the solids within Fusion 360, the software generates a center of mass for it. What this script does is that it calls that center of mass and converts it into a point in your design where that center of mass is. That's all it does. And if you Google like Fusion 360 center of mass script, you'll find Michael Aubrey's GitHub where you can download the center of mass point.py file. Just put that on your desktop wherever you like and just hit add under my scripts. Find your file, find the py file, just hit open, and there we go, it's available to run. And you can run it just by clicking the screen button. We'll do that later. Now, this workflow can be easily adaptable to any project really that wants to work with an existing mesh of either scanned data or export it out from CAD software and add parametric modeling features to it. And for our purposes, this will be just adding a little attachment point to make it an ornament. And the reason I chose this file in particular is this is the paraglider. I exported it out from SolidWorks a couple of summers ago when I was working on it as a summer project. And it actually has quite a few imperfections. Now, if you run this through a slicer, it'll look just fine. It'll process out very cleanly. That's because slicers can approximate out any errors within a mesh, like little floating closed mesh particles, intersections, holes, and all other problems that make it difficult for Fusion 360 to process effectively. And let me show you. While it may look fine to our eye, look very complete and very detailed, if you take a simple cross-sectional analysis, you will notice that there are these little things just floating around inside my mesh. These are leftovers from when I converted it from a CAD file. And these will really confuse and mess up Fusion because what it wants to do in our workflow here is convert this mesh into a single solid body. And when it has these little floating guys in it, it gets really confused. And here you can see a hole. This is just one of many examples of things that will easily confuse Fusion or any software in particular. So what we're going to do is that we're going to take this file into Autodesk Remake, clean it up for Fusion 360, and then start working on it. So let me show you how to do that. Hi everyone, now we're back. I have opened my paraglider file inside of Autodesk Remake, as you can see here, and I switched the wireframe view so it's a little easier to see any holes or errors within the file. Now, this process works best when you already have a solid file. If you have something from a 3D scan that's usually just a single surface, you're going to have to convert that into a solid or close it off some way, and I'll show you how to do that in another video. But for now, we're just going to work on this mostly solid part. Mostly fully closed part, I I should say. What we're going to do is that Remake already comes with quite a bunch of very efficient repair tools for your mesh. So we're going to hit the Analyze toolbar, find Detect and Fix Model Issues, and you'll notice that it very quickly found areas like holes, particles, and intersections, like I mentioned previously, that it wants to try and fix. And once we fix all of these, we can bring it back into Fusion. Since this is a very, how do I say this, geometric part, a lot of it has a lot of has just plain flat edges, so I'm going to hit flat for when it tries to correct holes by filling them in. Try and keep the original geometry, and hit remove all. What this does is that it goes through the process, fixes these imperfections best as it can, and we're just going to keep hitting detect and fix until it says there's nothing left and it's a fixed file. So rinse and repeat. You may have to do this quite a number of times until you get a nice solid mesh, and if you download something from, say, Thingiverse or My Mini Factor, any one of those 3D printed file public repositories, I guess you could say, it's usually good enough. It's usually already fixed and is very clean and ready to use. In which case, awesome. But keep in mind that if something goes wrong in this workflow, you may have to take a look at how good your file is. Ooh, perfect. Now it says no defects found. This is ready to bring into Fusion. So, actually, I'm not going to save as. I'm going to hit export. I'm going to export the model. And for now, this is another thing, Fusion 360 quads, that we won't be doing today, but it's another option for you if you choose. We are actually going to go into advanced, hit STL, take the coordinate system from the scene just because it's usually tighter and closer to the model itself. We're not going to decimate, meaning reduce the number of faces quite yet, because doing so would simplify a lot of geometry and necessitate us running through that whole detect, fix workflow all over again. And we're going to do that in Fusion. Or we're going to do something very similar in Fusion that will require less cleanup. So let's hit export. And I'm going to bring it and overwrite my previous file that I did this with, called ppg. Actually, we're going to name it ppg fixed. That means I repaired this STL. Hit save, and it's going to save this model. Excellent. Export complete. Now we can go back into Fusion with our fixed mesh and start playing around with it. Okay, everyone. Now that we're back in Fusion 360, we're going to insert our mesh under the Insert tab. Find Insert Mesh, find our fixed paraglider file, and just insert it into our design file. Notice that you have the option to move it to the center of your file or the ground level, and just another number of other transformations you can do to bring this closer to where your origin is and how you might want to orient your file. But that's not important right now, so we're just going to hit OK. Now, the nice thing about Fusion 360 is that it allows us to convert this graphic, this mesh file, with no center of mass, no mass properties for that matter, into a solid body that does have those properties. You can easily check this by looking at the properties of your design file and noticing that it says 0. Like I said, this is a graphic. It only exists visually for us. It has no mass. And this will make things difficult if we try and design something that is dependent on that center of mass, like an attachment point or a little hook for our Christmas ornament. So what we're going to do is we're going to enter the mesh workspace of Fusion, decimate this model so that we can turn it into a solid body, and then design in the parametric modeling environment. So, first thing you have to do, and this is a really important step, is that notice that under the environment drop-down menu, you don't have mesh available. How do you enable this? Well, you right click on your design, hit do not capture design history, and now it will show up. Now you have entered a direct modeling environment, meaning that a history of your actions is no longer kept, and that everything you do is just a commit. You're just committing to that action. Yes, you can Control Z and undo, but for the most part, if you do something, move something by a certain amount, it remains moved, and you can't just change a value. You have to either redo an action completely. So we're going to go into the mesh environment, and what I like to do is I like to make a copy. Because when we decimate a mesh, that is reducing the number of faces. And when we reduce the number of faces, that reduces the amount of detail we get. So what I like to do, and I would like you to do, is to copy and paste a copy of your mesh in place. This is useful. We will, I'm going to rename this reduced so that we can keep track of it while we're working on the mesh. And what we're going to do is we're going to convert reduced into a solid, design around it, and the center mass we generate from it. And when we have that, we're going to convert our parametric solids into meshes that we then combine with our original very high polygon, high detail mesh file. So that's one way of effectively preserving your detail. So I'm just going to hide mesh body 1, original, and start getting to work on reduced. What we're going to do, real simple, is we're going to reduce. This will look at this feature. We'll take a look at the geometry of your mesh and cut down the number of faces. So under the reduce target option, we're going to hit face count because the limit of this conversion into a solid is right around 10,000 faces. First, we got to select our mesh. So let me hit that. 10,000. Go. Hit 10,000. And the difference between adaptive and uniform is that under adaptive, if you have a lot of straight flat planes, it'll draw bigger triangles. And when you have a lot of very precise or careful curvature, it will break that up into smaller triangles so it has a smoother surface. And this is just a more efficient way of doing it. Adaptive, preserving detail where you want it versus where you don't. But a uniform allows you to get like equal sized equilateral triangles all throughout your model, which is in a way, in some ways, better for modeling when you're fusing with other features. Because Fusion 360 will have to remesh features anyway when you fuse 2 or more meshes. But for now, we're going to go with adaptive because we're not going to deal with this mesh other than turning it into a solid. That's all we want to do. So now we just have to wait for this to reduce. And important thing to note, this can be particularly harsh on Fusion, especially if you don't have a very nice laptop like myself. So if something says it's not responding or if it's being slow, just give it a minute. Just give it a minute. I, I promise you, Fusion is just working on it. So now we have our reduced mesh, and as you can see, comparing it with our original, we definitely have a lot less detail as a result of there so many less triangles being in the mesh. Now we're going to convert this into a solid. In order to do that, we need to enter back into the modeling environment, right click our mesh, and hit mesh to brep. This will effectively convert it into a solid body. Give it a minute. There we go. Now you can see this is a solid body. How can we check that? Well, if we right click, look under Properties, you'll notice now it has a center of mass. Fantastic. And by default, it assigns itself as steel, but that doesn't really matter because it's a uniform material. Now, um, another important thing to note. In order for us to use this script successfully and not get this error that you see here, we need to turn our design history back on, right click, capture design history, and notice that it brought back the timeline, and everything we just worked on is now a direct modeling feature. Cool. And we are going to go under add-ins again, hit center of mass point, run, let it run, and there we go. That is the center of mass of our object. Now, we're going to try and use this to generate a little hook on the top. And one of the easiest ways to do that is to construct offset planes. So select the plane, the offset, and in order to bring this to the distance of the center of mass, all you have to do is find the center of mass, hit it, and it auto-generates how far it has to be for that plane to intersect with the center of mass. Really handy tool. I'm going to start a new sketch, and in order to use this center of mass feature in our drawing, we're going to have to project it onto this plane. So just hit project, hit that. Notice that it becomes purple. That indicates that it is a projected sketch feature. And now we can use it to make coincident relations and basically tie a lot of the other sketch entities to it. So what I like to do, real simple, is just a center to center slot. Dimension that out. Let's say 2.5 meters. Whatever is good. This isn't a properly scaled model yet, and I will do that later in my slicer. Make this vertical so that we can very properly get a nice, tall, straight tower. And notice that it is now coincident with our projection of the center of mass. So that when I convert this back into a mesh, it'll be in the right place. And since I want this to intersect with the mesh, I'm going to cut it off right around there. Hit extrude. And I'm not going to make it a cut, I'm going to make it symmetric. And that looks like a good thickness. I'm actually going to make a new body because remember, we're going to convert this body into a mesh that will then intersect with our original mesh, or mesh body 1. Hit OK. And now, just hide some of these features. We have our original mesh body right here, our catted feature. Okay, so we're almost done. We have our handle that we catted, and at this point you may see fit to include other catted features like redo of this nameplate, patterns all along this base here. There's really no end to what you can do in the catted workspace, in the modeling workspace rather, prior to this merge. So it'd be wise to save and save this a version as prior to merge or something so that you can go back to it, because once we enter back into the mesh workspace to complete this merge, it will erase all of these sketches, extrudes, and so on. So we can't go back to them, which is a little annoying, but it's necessary. So use this as a checkpoint, rather, for your design. Now, we're going to turn off the design history, head back into the mesh environment, and convert this handle into a B-rep to mesh. And now you can see it's a mesh file like all the other meshes. But we're keeping the original body right here. So now we need to make these two as a single body. So selecting those two. And it might be useful to keep tool bodies if you want to use these bodies again in the future, further down your design. But for now, I'm just going to keep that unchecked. I'm going to merge the two. And now you can see this is just one file. This is second to last step, I promise. Now we're going to make closed mesh. What this does is that it takes these two intersecting meshes and retopologizes them so that they're one solid piece again. You have several different options here: standard, preserve edges, and accurate. These are just different types of how it will choose to retopologize everything so that it's made of uniform triangles and is one solid continuous surface for 3D printing. I like to use accurate, crank up the density so I have the most number of triangles possible, and give it a little offset so that some thin features like this propeller or these tiny holes here can be approximated out and be easier for my 3D printer to print. So I'm going to select this mesh again, hit OK, give it a minute. This is also another one of those very computationally heavy commands for Fusion to do. So if it says not responding, just give it a minute to finish working through the problem, and it will give you your result. So just, again, be patient. Now we're back, and we have just merged the two meshes together and made a closed one. And as you can see here, it is now retopologized. We lost some detail like the lettering and some of the hole attachment points and holes from the previous design, but for the most part, this is good, solid, and 3D printable. And in order to get this back out of Fusion and into your slicer, just right-click the mesh body in question, save as STL. This won't retopologize it further, and just save it to your desktop or whatever. And as you can see, if we do a section analysis, there are no imperfections within the mesh. There's no holes, there's no intersections, there's no particles floating around. This is one solid, continuous mesh, which is what we want for 3D printing. And let me just open up Cura to show you. Okay, so now we're in my slicer, Cura. We use an Ultimaker 2 Plus in the lab, so I like to use Cura to prepare my 3D printed parts. I am going to find my Mesh Body 5, our modified paraglider. There we go. It's a little big, so I'm just going to scale this down. Reorient it slightly. And now we have a 3D printable little paraglider ornament that is now mass balanced about its center of mass. Thank you. I hope you enjoyed the video and you can use this workflow to make your own 3D printed ornaments within Fusion 360. Thank you for watching. Have a nice day. Happy holidays.